Hey guys, welcome to Unit 5. We are going to be in this is Chapter 5, not Unit 5. We are going to be talking about our first lesson. And so in this unit, our lessons are going to not really go along with the book that much. So I'll kind of warn you as we go along. This kind of has some of Lesson 1 and Lesson 2 in there. So you guys, this should all be a review. So I'm going to do the first one for you, and I want you to see how much of this you can fill out. So if I have x to the fourth times x to the sixth, that is the same thing as this. So let's see, 1, 2, 3, 4, 5, 6. Yeah. So notice that there are 10 x's. So our answer is going to be x to the 10th. Oops. And so the rule is that you add the exponents. 4 plus 6 equals x. So you have similar bases, you add your exponents. Okay, so go see what you can do on the other example. Okay, so let's start with example 2. So if I did this to the fourth power, I'm just repeating and then I'm adding the exponents. But the shortcut is you would multiply the x squared times the 4. So when you raise a power to a power, you multiply. Example 3, 4, and 5 has to do with division. So I'm canceling out the x's and I have 2 x's. But the rule is, a shortcut rule of that is that when you have an exponent on top, exponent on bottom with the same base, you subtract the exponents. So here, let's go ahead and follow that. So here I'm showing you that everything cancels out, so my answer is 1. But what it looks like algebraically is I'm going to take x to the 6 minus 6 power, and we end up with this x to the 0. So anytime you have x to the 0, that means that everything is canceled out and you're left with 1 every single time. This one, we have 2 x's on bottom and none on top. So my answer would be 1 over x squared. That is the same thing as x to the negative 2 power. So when you have a negative exponent, we move it to either from the numerator to the denominator, or in this case, from the denominator to the numerator. So that's how you do with negative exponents. And then finally, this one, I showed it from this perspective, just squaring it. But another way is I'm going to distribute this 2. So I have x to the first, y cubed. And when I distribute that 2, I'm going to have x squared y to the 6th, because when you raise a power to a power, you multiply. Okay, so those are the 6 rules that you will ever come across. So I'm going to throw a lot of different things at you, but it always comes back to those 6 rules. So let's go ahead and see what you can do. Again, this is review, but see what you can do on this example 1. Okay, so here, the biggest mistake that I see people make is they want to multiply those bases together. So it stays the same. So 3, 3, 3. And then you add the exponents. So 3 to the 6. Same thing here. I'm going to add the exponents, but I ended up with a negative exponent. So it says it should only contain positive exponents. So I need to say 1 over 2 squared. And you can take it all the way if you want, 1 over 4. This one I raised a power to a power, so I multiplied those 3's together. On this one, this guy wasn't happy on top, so we moved him to the bottom. And then I'm just adding these exponents together. So I have nothing on top. I just have that. So we have a filler. So we have a 1. And then I have the same basis. So I have 3 to the 3rd plus 3, times 3 to the 1st. So I'm going to add those exponents and get 3 to the 4th. So 1 over 81. This one, I raised a power to a power. So I multiplied, I ended up with this, and then I added them together. So I get 2 to the negative 20. So again, it's negative. So we want to say 1 over 2 to the positive 20 power. This guy wants to be moved to the bottom, and this guy wants to be moved to the top. So remember, if we have, and so I have 2 to the negative 2 power, or 1 over 2 squared, which is 1 over 4. So this is a 3 to the first. So I have 1 minus 1 is 3 to the 0 power, which is just 1. So I'm left with 3 to the 4th, or 81. And then this one, I just added all these exponents together, and I got 3 to the negative power, which is the same thing as 1 over 3 to the positive power. And you can turn that into a big number if you want. Okay, so now we're going to move from, notice these were all numbers, same concepts apply, except we're going to move on to exponents. So see if you can do. Okay, so let's go ahead and go through these. So this one is pretty basic. Just know that that 4, like every man for himself. So that 4 is by himself. We're going to combine the x's and we're going to combine the y's, which there's no y's there. This one, everybody was not happy. They were negative, so we're going to put them below the fraction. This one, this guy wasn't happy on bottom, so I moved him up on top, and then I combined them. 4 plus 2 is y to the 6th. And then I had 2 x's on top and 3 x's on bottom, so I was left with 1 x on bottom. This one, I distributed that 2, and then I combined, so my x's, I had x to the negative 4th, and then I had y to the 12th. So that negative 4, the x was not happy, so he moved to the bottom. For E, I distributed everything, that 2 to everything, and I ended up with this. And then I just I had 8 x's on top and 6 x's on bottom, so I was left with an x squared. Other than that, that was pretty straightforward. Okay, so I left F because there was a lot going on. So I was left with y to the negative 6, y to the negative 6. So anytime you have the same thing top and bottom, it's going to cancel out. So I wouldn't even worry about that. This 3 to the negative 3rd, he's not happy on top, so he's going to go down below. And then I have 9 x's on top and 12 x's on bottom. So I'm going to be left with 3 x's on bottom. So I need a filler, so I'm just going to add a 1. So the only thing complicated about this problem is these z's. And so I just subtracted. So anytime you do it this way, if you end up with a positive exponent, it's going to go on top of the fraction. If you end up with a negative exponent, it's going to go below the fraction. Okay, so this one, it's going to say, it says write as a power of 2. So you're going to ask yourself, maybe play around on your calculator. 64 is 2 to the what power? And 128 is 2 to the what power? So see if you can do both of those. So 16 is 2 to the what power over 256 is 2 to the what power. Okay, so this is what you should have gotten for these two. Notice the step here. And again, you can totally use your calculator to kind of figure that out. Okay, so we're going to talk about scientific notation and how it appeals to, or how it applies to exponents. So this is a number, all 3 of these are numbers in scientific notation. So, okay, so to solve this, the first thing I'm going to do is multiply everything through together. So when I did that, I got 14.4, and now I'm going to worry about the exponent. So let's pretend like I just had x to the 5th, x to the negative 4th, x to the negative 7. So let's see, I would add these together. So I get x squared over x to the negative 7. Well, that is not happening on top. He's going to come up here. So I'm left with x to the 9. So that's what we're going to say. We're going to say 10. Instead of x to the 9, we're going to say 10 to the 9. Okay, so when you have scientific notation, don't forget that it's a number between 1 and 10. So I have to move this over. So because I'm making this smaller, I'm making this value smaller, I have to make this value bigger to kind of counteract it. So my final answer would be 1.44 times 10 to the 10th power. And that is it, guys, for our first lesson.